Hello, my name is Nathan Russell. Today I'll be demonstrating stochastic differential equations and how they can be applied to markets to predict future trends, future macro trends. So I'm using a GBM method. It's a geometric Brownian motion. It's an equation that models random volatility in the stock market while still using drift to predict an upward trend. It's generally good for predicting using historical data, predicting what direction any kind of complex system like this is going to go in at some time in the future. So all of my data points are being pulled off of Yahoo Finance. Yahoo Finance collects all of this data and compiles it into a document that I'm using with a Python script. So I'm pulling that code off of Yahoo Finance and using it to plug in each of these variables. And then thankfully Python also has an equation model that I can use, so I don't have to plot the entire stochastic differential equation by hand. That'd be brutal. That'd be brutal. I wouldn't want to do that. Okay, so fundamentally, this differential equation is modeling stochastic growth of the ST, which is the stock price, and it's combining both the drift and the volatility to get a comprehensive equation. This would only measure one single general predictive trend line. So we actually do this 20 different times to get 20 different trend lines which are all relatively random, but then we average all of them to get something that we can actually use. It's actually usable to predict the future trend of the market. So this kind of goes into depth of how we're using this drift and volatility. This is just an annualized drift, and this is the standard deviation of logarithmic returns. We use the square root of 252 because that's how many trading days there are in the year. Here's the other differential equation. So this is the part where we apply the geometric Brownian motion. So we're actually using both of these. One is to get the trend line, one is to get the averages. And so now I will jump over. Oh yeah, a little disclaimer here. This is not accurate to predicting. Um, it's not going to predict the little upticks in the recessions. It's never going to be able to predict when Donald Trump releases tariffs or something. If it could predict those trend lines perfectly, we'd all be millionaires. But it can't. So just a little disclaimer there. So yeah, these are some graphs that I pulled earlier. But let's actually go over to the model itself and let's see it run. So we'll run this code. There's quite a bit of code here. I'm not going to jump into all that. But you run this code, and boom, it pumps out these graphs. So these graphs, this one is more of just a benchmark. This graph is making sure that it works. So it plots these blue lines are each individual point. So the blue lines represent individual differential equations that have been ran based off of the historical data throughout this entire time period. The red line that's plotted is the average of all 20 of those. So I was just plotting this to make sure that it was accurate, which, as you can see, it definitely is. Obviously, it's not predicting COVID, and it's not predicting any major recessions here. You're never going to see that with something like this. But the trend line itself is generally very accurate, and that's what we want to see. So now that we know that this model actually works, we can kind of look into the future. So here we are looking at this is it's not graphically represented here, but it's taking data from the past 5 years here and it's projecting that out into the future. So it's saying, okay, we have all this data from the last 5 years. Let's take the average volatility from that entire period. Let's take the average drift from that entire period, and now let's run a bunch of simulations incorporating Brownian motion, and let's see what we get. So here's all of our data simulations. You can see it gets up to as high as $2,000 by 2030, as low as even like mid 300s over here. But the average trend line is pretty consistent. That's about what you'd expect. So this is taking data from 5 years and projecting data out 5 years. This one is taking data from the past 10 years and projecting it out 2 years. Um, and we're getting returns here. This is actually pretty consistent with what we would see in the market. So I'm very happy with the way that this model turned out. So 5 years, 98% return. That's pretty realistic, right? The average rate of return before inflation of the S&P 500 is somewhere between 8 and 12% most of the time. This is saying that an average growth rate over the next 2 years is predicting 24%. We've also got some of the fifth and 95th, some really high outlier data points. You can mostly ignore those. That's just kind of gives you some boundaries between which our data is going to be most accurate within. Um, I'm planning on actually uploading all of this to a website and having it refresh every couple of minutes, so that we can get a real time projection of these graphs in the future. Like I said, this is never something that's going to be used, and it is not something that should be used to predict recessions or to predict bubbles, or really even something that should be used to predict the future of the market at all. And this would work on anything. This would work on major indexes as well as individual stocks. More so, what this is, it's a general predictor to get kind of a good idea of a macroeconomic trend. That's all.